Okay. Let's see here. Focus and zoom in. So we're going to be doing equations of the quadratic type again, but it's going to also involve the Pythagorean identity. And so the idea here is you're going to have an equation that it'll involve like two of the functions from the Pythagorean identity, in this case sine and cosine, and one of them is going to be squared and the other one's a linear term, okay? And we're going to be able to use the Pythagorean identity to get them all in terms of the same trig function. Okay, and this will be similar here, but this one's with secant and tangent. But notice secant and tangent go together in the Pythagorean identities. So these will work when you have sine and cosine, secant and tangent, or one that involves cosecant and cotangent. Okay, but it won't necessarily work if you have a sine and a tangent, or a secant and a cotangent. Okay, they have to be the one that is related together by the two that are related together by the Pythagorean identity. And of course, for sine and cosine, the Pythagorean identity is like we usually write, it doesn't matter which one's first, but cosine squared x plus sine squared x is equal to 1. Okay. And if you notice here, we can change this sine squared x into the cosine. Okay, I can do that by solving here for sine squared x. And so what that means is, in for the sine squared here, I can put this. Okay, I'm using the Pythagorean identity. And so what you're going to always do is you're always going to take the equation and change it to the one that's the linear term. So in this case, the linear term is cosine. So I'm going to change the whole equation into cosine by using the Pythagorean identity this way, substituting it in. So in doing that, I would get this. I'm going to substitute that in. Okay, and now you see I just got cosines in the equation. So now I can distribute 6 minus 6 cosine squared x is equal to 8 minus 7 cosine x. Okay, so now we're going to bring everything to one side and then put them in descending order. So I'm going to bring this over to this side, but I'll write it on this side of the equation. So I'd have 2 cosine squared x when I bring that over, and then I'd have minus 7 cosine x, and then I'd have to bring this over, and that'd give me plus 2 is equal to 0. Okay, so this is what I have. I have an equation of the quadratic type, and I might be able to factor this, but I cannot remember. I don't think I can factor this. So what I'm going to do is I'm going to use the quadratic formula to solve, and when I do, let's see what happens. So I would get that the cosine of x is equal to the opposite of b, so the opposite of negative 7 plus or minus the square root of negative 7 squared minus 4ac all over 2a. Okay, and I'm going to use, this would be 7 plus or minus, and I'm going to use my calculator to calculate what's on the inside. So that would be 49, but then you would have 49 minus, what is this, 4 times 6 times 2. And that is that ends up becoming 1. So like the square root of 1, which is just 1, all over 12. Okay, so I'm going to get these two equations. I'll get like cosine x is equal to 8 over 12. And 8 over 12 is 2/3. And then this one will be cosine x is equal to, that would be that would be 6 over 12. So that would be 1/2. So again, I got a special point on the unit circle here, and one that's not a special point. So quickly here, you're going to get really good at these basic trig equations, aren't you? So you'd have this point up here, which is pi over 3. The one down here is 5 pi over 3. So you have these two. And you know, that is so small. I am so sorry. I'm going to zoom in. Okay. And so this would give you pi over 3 plus k times 2 pi. And 5 pi over 3 plus k times 2 pi. This one is not a special point on the unit circle. So this would be like 2/3 here, right? And you'd have 1 up here, 1 down here. So using the inverse cosine of 2/3, I get like 0.841. So this is like 0.841, and that's one of them. This one over here, you'd be going down 0.841, so I'd take 2 pi minus 0.841, and that gives me like 5.442. Okay, and so boy, I'm gonna run out of room, ain't I, to do these. So maybe I'll put them over here. So one is 0.841 plus k times 2 pi, and then one is 5.442 plus k times 2 pi. So these would be the solutions to the original equation. So what you're doing is you're taking, if you have something that involves two functions that go together in the Pythagorean identity, you're going to change, and one's squared and one is linear, you're going to change everything to whatever that linear one is by using the Pythagorean identity. Okay? So we're going to be able to do the same thing for this one. So if you remember, the identity here is that tangent squared x plus 1 is equal to secant squared x. So I'm going to put a line here and just say, make sure, in case you go back and look at this, this is the identity. Okay, so that relates these together, and so what I'm going to do here is I can solve this for tangent squared x, right? And this is equal to secant squared x minus 1. So funny, because this is so similar to the identity, isn't it? So it's a little confusing. But the point here is this is the linear term, right? This is the squared term. So I'm going to change everything to secants is what I'm going to do, right? So so this tangent squared, I'm going to put in, for this I'm going to put in secant squared x minus 1. So now I would have secant squared x minus 1 is equal to 1 minus secant x. And so now we'll bring everything to one side. So if I bring this over, I get 2 secant squared x. No I don't, sorry. I would get the secant squared x here. I would get plus secant x. And then this would come over, and that would be minus 2 is equal to 0. So it'd look like that. And this thing can actually be factored. It could be factored into secant squared x minus 2 and secant squared x minus 1. Okay, and so sorry, these are not squared. These are not squared. Sorry, it would be factored into secant x minus 2 and secant x minus 1. Sorry about that. So basically we got these two equations. Secant x is equal to 2 or secant x is equal to 1. Okay, and both of these have a solution. Okay, because secant is the opposite of sine and cosine. So you don't want it between -1 and 1. Okay, and this is a solution because remember the secant goes down, touches the cosine, and goes back up. So that's actually a solution. And in fact, what I can do is I can rewrite this as cosine x is equal to 1/2. And so this is just by putting secant x as 1 over cosine x. And so I get 1 over cosine x is equal to 2. And you can solve that and get cosine x is equal to 1/2. And this would be cosine x is equal to 1. So you're really solving these two. And I solved this one here. So x is equal to pi. I solved it down here. X is equal to pi over 3 plus k times 2 pi. X is equal to 5 pi over 3 plus k times 2 pi. And this one, cosine x is equal to 1, occurs right there. And so this would be x is equal to 0 plus 2 pi, k times 2 pi. So I could just write k times 2 pi. Okay, so these would be your solutions for this equation up above. Okay, zoom out here. Okay, so these are equations of the quadratic. They end up being equations of the quadratic type, but you have to use a Pythagorean identity to get them into that that form. So coming up next, we're going to do several different equations that are going to kind of use factoring and identities kind of together. Okay.